Yeah, hi everyone. I'm Ethan. I'm the Apache Hudi committer and database engineer for Onehouse. So next, I'm going to go through like what's coming next from the community. So in terms of the roadmap, we have two releases coming up after the 0.12 release. So the next major release is 0.13.0. So we're going to have major features, which I'm going to talk about in the next few slides. I'm the release manager. So the next minor release coming out is the 0.12.1. The release manager is Zhao from ByteDance. So for the 0.12.x, we are aiming for the stable releases, meaning that users can directly upgrade to this release from any older release for like stable upgrades. So for 0.12.1, we are aiming to release that early in Q4 2022. And for the 0.13, we are aiming to release it before the end of 2022. After that, we plan to have another minor release for 0.13.1 as well. Could you go to the next slide? Cool. So I'll go over the major features we plan for the 0.13. I'll talk about three areas: the transaction DB layer, the programming APIs, abstractions, and also the platform services. So all of these are coming from like contributors from different companies. So any new contributions for RFCs are also welcome. So let's first go through like the core transactional DB layer. So one of the major thing we aim to roll out is the metaserver for all metadata. So if you look at the Hudi at this point, we already have like a centralized timeline server, which serves the file system view through like remote procedure calls. So how it works is that if you're running a Spark job, basically the different Spark executors can reach out to this timeline server hosted on the driver side for all the file system view related information without having to scan the Hudi timeline or the table themselves. So this is very useful for streaming data since this is going to return the information really fast. So beyond the file system views, we're also thinking that why not providing such metadata from like a metaserver for all like the index, for example, column stats, Bloom filters, to speed up like both the write and read side. So for example, for the query engine, currently we have to scan the index individually for each query. So that can be costly. So if we have this metaserver, then we can speed up the planning by order of magnitude and improving the query performance. So that's about the metaserver. Alongside the similar lines, we are also thinking about how table services can be better managed and coordinated. So that is where we want to introduce the supervised table service planning and execution. So the problem we are tackling here is that currently all table services are kind of planned and executed in each ingestion job, or even in individual execution tasks. So if, for example, in production, there are so many tables to manage, this can become like operational overhead. So what we are thinking that if user want to have like a centralized manager or centralized scheduler, then they can like coordinate all the table services or even do some optimizations around how to better schedule different services like compaction, clustering, cleaning, so that they can save resources. So this is how we want to introduce the independent service scheduler, so that people can choose to coordinate all the table services. So both the metaserver and this table manager or coordinator will be like an add-on. So by default, user can still choose not to use it, but if they deploy this, they should expect like drastic performance improvement. So beyond that, we are also pushing the support for the change data capture data model. So what we actually want to do is that, so this CDC is becoming actually popular in recent years. So from Hudi side, we already support these incremental queries to get like the kind of the latest data from like time from like a time instant. What we want to support more is to actually conform to the CDC format, where we can provide the actual changes from the Hudi table similar to the Debezium format, so that at the record level we know like what are the column changes, whether like a record is deleted. So in this way, if user choose to do like a CDC query, they can also do that from a Hudi table. So could you go to the next slide? Cool. So continue on the transitional database layer. We are also, so the community is also pushing more new indexes. So the first one is the record level index. So the problem tackled here is that for the existing indexes like Bloom index or simple index, they can fall short in scanning the index data or the joining overhead. For example, for the Bloom index, the right job has to scan the Bloom filters and then look up the record key to figure out which which file ID or which file group this record falls into, so that in the subsequent stages, the abstract can perform more efficiently. One problem is that Bloom filter is suited for like more ordered record key, so that you can prune the files to be updated. But in some cases, if the UUID is used as the record key, then there are more random updates, or if the ratio of updates are higher, the Bloom index may not perform very well. So we are trying to see if we can reduce the overhead of index lookup. That's how this record level index come into place, where we want to store the direct mapping of record key to the file ID, so that the index lookup is really fast. Then it can even avoid the actual joining between the input batch and the existing data. So this is driven by Uber. They already have a POC in their like production, like serving like some tens of terabytes of metadata in this record level index, and it's working pretty well. So we aim to land these in open source as well. So the next index improvement is for the consistent hashing index. So the problem here is that we are trying to overcome the sorting issues for very large tables, and how the records and files can be better distributed on the storage. So we already have like a consistent hashing index. We are trying to bring like a dynamic buckets to it, because currently if the bucket has too many records, the file size can be really large. So we are introducing a new design where like the bucket can be dynamically split into smaller ones, so that you can scale to like very large tables and like data SKUs. We are also introducing the secondary index in Spark to improve the query performance. Sounds good. So next slide. So yeah, so beyond that, we are also introducing some other improvements to the MOR compaction and concurrency control and such. So for this log compaction in MOR, so the problem we are solving here is that if there are more frequent updates to an MOR table, especially for the metadata table, there could be additional log files, smaller log files. And on the read side, merging this log file with the base file can introduce a lot of IO inefficiency. So one solution to this is that you can basically do compaction to to merge the base files and log files. But the problem is that these also increase the write application. So that may not be ideal for like a very large data set. So we are trying to introduce like a middle ground between the full compaction and like the MOR with delta logs without any compaction. So we are introducing this new operation called log compaction, where we just compact the log files without actually touching the base files. And we compact these log files into a single one so that it can balance the write application and error efficiency. So in this case, after log compaction, there are fewer log files, so the merging cost is lower, but still like you don't have to rewrite the base file, which is usually larger. So this balance the write application and error efficiency. So on the concurrency, optimistic concurrency control side, we are introducing a new mode called eager conflict detection. How OCC works now in Hudi is that we let multiple writers to proceed writing data, and only before the commit time to guarantee transactions, we check for any conflicts, and we reject or we fail the commit that has the conflict with the later commit time. However, the problem is that if both writers have a lot of data to write, so we waste the resources for the second writer that has the conflict. So we are introducing this new mode where we can detect the write conflict from the second writer much earlier using the marker files, so that we can abort the job much early in the stage whenever we detect the conflict, and release the resource so that the resource can be reused for other ingestion jobs. So lining up in these release, we also want to improve like the bootstrap and migration of non-Hudi dataset. So this feature is actually put in like 2 years ago. We want, as we introduce new indices and other new components in the transactional database layer, we want to make sure these can work well with the existing components. And we are also considering eliminating the physical partitioning with a more efficient logical partitioning and file pruning. So essentially, the idea here is that physical partitioning is going to actually force the file pruning by specifying the partitioning value. However, as we introduce like different indices and metadata table in Hudi, we can actually do more or can do better file pruning based on the index, and even do like a function of a column in the predicate so that we can prune the files better without even doing physical partitioning, so that user doesn't have to worry about which partition column they need to choose. So that is the idea. Sounds good. So let's move on to the next section. So regarding the programming APIs and abstractions, we have 3 major improvements. So first is the redesign and optimization of the record payload abstraction. So the problem in Hudi now is that historically we rely on the Avro format for different engines. And the problem of using Avro is that we have to convert the Avro format into different engine native formats such as row in Spark. And that actually introduces performance penalty. So we want to redesign the payload abstraction and API so that it can better support different engine integrations. So this is like a big overhaul for the payload abstraction and merging logic. So if you are interested, please also look at the RFC and provide your comments. So next up is for the storage layout for cloud object stores. So as you all know, like cloud object stores like S3 enforce the RPC throttling for accessing files. So this becomes a big problem if there are so many partitions and many files in a single table, especially on S3. So we are providing this interface for customizing the layout strategy. For example, instead of storing like inside like a single root table path, we want to have some prefix so that basically the folders or the prefix are shuffled across different strings, and to avoid the throttling from the S3 side. So we provide this interface so that user can even customize for their own logic of how files are distributed in the cloud. And we also, besides that, we're also introducing this semantics of verification for multiple event time. So that's all for the programming APIs and abstractions. So next, I'll briefly talk about the platform services. So we have three improvements here. First is we are introducing the protobuf source for data streamer. This is like a new format inside the source. And we are still working on the Hudi integration with Snowflake so that Snowflake can read Hudi as external table. And in terms of the debuggability, we are improving the Hudi CLI features and usability so that whenever user has problem, it's easier for them to use CLI to understand the issue. And we are also working with the AWS EMR team to make this Hudi CLI jar usable out of box, so that user has less friction to use that on EMR environment. So hope that gives you like an overview of what's coming next in the 0.13 release. And we always welcome contributions from the community. If you have new ideas, feel free to send an email in our dev list and also bring up the idea in the Slack channel. And yeah, feel free to join the Slack channel if you haven't done that. Yeah, so that's all. I'll hand it back to Sudha for the open floor.
All right. Thanks, Jayashil, Isha, and Prashant for enlightening us with your use case. I'm pretty sure there'll be like a lot of interest in this use case across the community, and I've been hoping to get a lot of questions on this today or like offline in Slack. And thanks, Ethan, for like walking us through the next major release work and RFCs. I think we can open up for questions.
Yeah, I think that's a really good summary. Thanks, Ethan, for summarizing it. This is Raymond speaking. I'm just want to also add some notes there for community collaboration. So yeah, it's actually a Hudi community that's actually very active and healthy. We deeply engage with different corporations and teams to push this RFC. So the RFC that Ethan just walked through is most of them are driven by the contributors from different companies like ByteDance, Alibaba, Uber, AWS, all these yeah, big companies, and also other active contributors. So yeah, I just want to highlight this this kind of activities there.
Yeah, definitely. Thanks, Raymond. All right. Sorry, anyone had a question? Okay, I think we can close early. Hoping to see you all in the next month's community sync. We can still follow up on Slack. Feel free to ping and ask any questions. Thank you so much. Have a wonderful day.
Thank you, Sudha, and all from Hudi community for giving an opportunity to speak here. Thank you very much.
Thanks, everyone. Take care. Bye-bye.
Thank you.
Bye.
Bye.